really good to see you all here. It's really good to see you here. And massive thanks to Playtech for being such a great host and providing us the spot and snacks and the drinks tonight. And for today's agenda, we have two talks. One is by Playtech's very own Stanimir and Allar on war stories about technical decisions and architectural decisions that went south at Playtech. And the second one, a guest from Prague, Czech Republic, Daniil from Wrike, will tell us a story about, about the the way they manage encryption key in Wrike. I guess it's an internal product that you use, right? All right. So so that's gonna be the agenda. And for now, I would like to welcome on stage Raul.
Thank you. Thank you, Stas. It's very nice to see so many of you out here after such a long time. Some of you we see more often in different dev clubs. It's really a pleasure to host Dev Club once again in Playtech offices. For the ones who haven't been here, you have a chance to look around a little bit, take an office tour between the two talks. For the ones who don't want to walk around so much, you can enjoy the refreshments. But without further ado, I would like to bring on our own Stanimir and Allar.
From these. And the number of topics is 8, because 8 is the number of years Stanimir has been in the company. So it seems that 8 is a very fitting number. All right. And I think I should start with the cloud, the mighty cloud. Years ago, all conferences were full of cloud talks. Everyone were going into cloud, and obviously Playtech didn't be different. We wanted to be cool. So we started our own cloud project to move our monolithic, that's a derogatory term, right? Monolithic service into cloud. Obviously, the coolness wasn't the only reason why this was attempted. There were actually some very good reasons. For example, the whole maintainability of our setup and setup systems, they were all house-grown. And finally, be able to rely on external tooling was kind of neat. Also, there were some promises about scalability. At least I was QA at the time, and this is what they told me. But right from the start, some interesting issues occurred. First of all, it turned out that we couldn't do a proper cloud. And by proper cloud, I mean the public cloud. we had to do our own private cloud because Playtech does a lot of gambling business, and this is very regulated market, very regulated topic in general. And there were some very strict legal reasons why we couldn't do public cloud at the time. Also, tooling was a huge problem. We relied a lot on reading logs. And suddenly our old tested ways of debugging stuff by reading logs and doing remote debugging, it just didn't work anymore, or we lacked the proper tooling for this. So things started to crumble, and people lost faith in it. No, because without this tooling, people didn't really want to deal with this. They didn't want to be part of the cloud project because it was kind of brought a lot of friction in their daily work. So in the end, the cloud project failed, but it wasn't that bad. There was a lot of refactoring done. We had some systemd integration done and various nice things. But still, the main purpose going into cloud with our main monolithic service-like thing didn't pan out. And one of the main reasons was that, yeah, private cloud, it is hard because you don't win much from the external tooling because you have to maintain everything, all the infrastructure. And we lacked some important tooling for developers, for QA, and people didn't just like to work on it. And I think one of the things that retrospectively we can say is we tried too much with too little time. We tried to make sort of a great leap forward, whereas more incremental change would have been more appropriate.
Right. So this is remembering my first day, maybe really the first day with the company. I got to lunch with two guys. One still with the company, the other is not. But anyways, and they told me about something that I was really surprised to hear. And they told me about something called OOTP and Redis, and there'll be another one later down the road. So what happened is, in the backstory goes like that. Same year, that's 2014. Company had a massive event, unprecedented to that time, of hosting Grand National, which is a horse race in the UK, and it's extremely popular, like extremely, I mean, everybody bets on it. It's kind of like a national sport on one day to bet on it, which means you have a lot more load, and a lot more load in a very specific moment of time, which is just one race. So what happened is the system went down, and it's not good, and whatever happened to it, and they wanted to refactor it in a way that reduced the stress of Oracle. So one thing that probably should be known, Playtech has this gambling thing, and it has this monolithic thing that is being called. It's not really monolithic because Playtech has like dozens of services. But just one of them is more prominent, it's called Nova. So this Nova was supposed to be able to do something really, really cool, which comes with this ACID part. Suppose most of you know about ACID, or at least I've heard about it. This is atomicity, consistency, isolation, and durability, which comes with standard relational database transactions. They get them for free, and people have them free. So the database of choice has been still is Oracle, which is expensive, but really not cheap at all. I mean, it does what it does, but costs. And it's scaling it costs even more. So you just have to pay even more. So like a bright idea was to store transactions in Redis, which means that you're going to lose acidity or whatever that is part of this ACID, because you want to store them in another. What can I do better? Instead of storing transactions in database, you store them in Redis and then group them, batch them together and send them to Oracle, which will reduce the I/O. But listeners consider it a really cool thing to do. I mean, that required, however, to make Redis clusters. Redis didn't have clustering done, and it was homemade clustering. And the entire part was really homemade, and I'm homemade for first time doing it. And the worst part of it was that it didn't incorporate monetary transactions at all. It was only concentrated on kind of logins and login-alike stories. So, I mean, while we actually don't really need all the acidity part of ACID, the transactions, you kind of need most of them. I mean, I'll be happy to go with two. Technically, I can give away the atomicity, I can give the isolation. I still want consistency and durability, because when I want to store things, I want to be able to read them. So the entire part went to first how it worked. It went to Redis, and from Redis, someone took it out, tried to batch it per different end user, and send it together to Oracle. This entire thing really failed, and there were cases when we again went black during this Grand National event. But different reason this time. This time the reason was that Redis ran out of memory. And it's just, that's how it is. And it was really difficult to navigate. And everything was homemade by that time. And the worst part, at least to me, is that we tried to do something. We had performance tests, and they didn't support the idea that this was good, it just wasn't. So then the other part is you start to store it in Redis for no apparent reason besides it's cool. Because my kind of, at least, personal experience is the Redis is like at least 3 orders of magnitude slower than storing things in memory in Java, because the service is built in Java. So in this particular case, it was really unsuccessful. Fortunately for us, and I say fortunately, this part died. However, there was something else that happened along with Redis. It was not Redis at all. It was Redis and data nucleus. Now, any of you has experience using ORM tools, JDO, Hibernate, JPA? Anyone? Okay, something, a kind of a thing. Okay, so I love JDO, and I'm just saying it like I really love it. It was 2004, and I was part of JDO committee. And I really believed in this thing. I really did. And I really loved it. I mentioned it, but it's still true. And when I came, this Redis thing that it has to happen actually had to happen along with data nucleus. So data nucleus it's a JDO implementation, which means it takes objects from Java and does things kind of automatically and sends them to Redis. Now JDO data nucleus does not have bindings for data nucleus, doesn't have bindings for Redis, so in this particular case, they were developed internally as well. They kind of violated everything that it has to be done. Worst part of data nucleus is the implementation that nobody likes. Kind of neither Google nor IBM, and then not Oracle bought it, so it became kind of independent, but that actually is the only reason you pick it, because it's actually free, which fit the bill in this particular case. And we had this experiment to try to fit our existing database model to JDO, to go to Redis, from Redis to make batches, and then remember the previous thing to send them to Oracle. This thing was absolute nightmare to debug. We have a lot of lessons to take from this. My first one is the first one. It goes there. Don't mix JDO kind of ORM stuff with key value data. So just don't do it. It doesn't work well. It's just not meant to do that. The entire relational model it's not there, and it didn't work. The other parts, of course, the JDO itself, retrofitting a model to JDO is hard. It just doesn't really work well when you have a model that is so vast, that is so large, and you try to fit it. The worst part, however, was not that one. You'll hear more about it, and I left it here. It's that this thing didn't have any tooling. And the worst part is how you work with it, is that it needs to enhance. And JDO, like I mentioned, was the thing that nobody wanted to use, a kind of buy to develop it further, it didn't have good enhancing tooling because JDO requires a post-compilation process to be able to build its own magic behind the scenes to work. Fortunately, they didn't have any bindings for any IDEAs like Eclipse or IDEA or anything, and what you have to do pretty much rent from Maven. Now, the downside of running it from Maven was that if you have any compilation that it's in your IDEA, we overwrite Maven. So when you start your server, which takes, let's say, 2 minutes or 3, your IDEA will overwrite what you had enhanced by Maven, and that thing is a failure. The other thing is this thing, like last year, finally managed to be stabilized, and I wrote an auto-enhancing class loader that actually does the enhancing automatically instead of using Maven to do it. So now when you run it, the process, it gets the classes, recognize the ones that are enhanced and not enhanced. That's one of the things that we finally did, and I said we delayed it at least 5 years. It was extremely painful process that it will be presented to you a little bit more.
So data nucleus and all this enhancement Stanimir talked about wasn't enough. We got another one, and this time it was aspect J. Now, around 2017, we had a lot of different data stores and ways of communicating with the database in our server. So we had Redis, and we used JDO not only for Redis, but also for the regular Oracle.
And for us is that it was really massive undertaking. Yet again, it took years of writing, supporting it, splitting the code, and doing all kind of funny business. And what you learned is the change is hard, and you probably not attempt to do that once again. I mean, people ask if you can do it with Postgre. Maybe it will be easier because Postgre is more similar to Oracle. Certain Oracleisms and part of the database dialect are kind of better there. We didn't do that. And what we learned is that when you have a vendor lock-in, it's really, really hard to break out. And that's one thing that you know. If you do it, just try not to use too much of specific vendor properties. Try to use standardized features that if you need to move out of it, you'll be able to do it, because at some point, everything is so locked in that you just cannot move out of it. And now, this is better. This is a picture. It's a true story picture. It's a marriage. And one of the interesting parts is this picture is here for a reason. The previous picture were there because we just could put them there, and they didn't make us remove them. But this stays for a reason. And now here the reason. And the reason is that breaking marriages and wedding vows and everything is much easier than breaking protocols. Those guys signed the protocols, but for marriage it's much easier. Protocols that you have established with other companies, whole new story. And I'm speaking from personal experience here. I mean, I literally, and this is true story, and I won't lie about it, I managed to get divorced without knowing. Like, totally true. I'm not joking about it. It's absolutely true. There are lands of infinite opportunities that this can happen to you. So, yeah, there you go. Those people, 50% of those marriage couples, they're going to get divorced, so it's okay. But very unlikely 50% of your protocols are going to go bad. And Playtech is enamored with protocols. Playtech loves protocols to a point that Playtech will have internal competition, name, concourse, whatever you call it, with prizes to name the next protocol. I kid you not, that is true. There are two of them that are kind of more famous. One is Gaming Power, the other is Galaxy. Galaxy is a mainstay protocol for us. And it still is. And even though it has this, grandiose name, it's not so bad anymore. So the point is that we introduced through the years quite a lot of protocols, even through my time. Even through my time, we didn't introduce new protocols. Well, there are already quite a few of them. Alight, we introduced one, Quicklink, which you'll hear about it. And we had the protocols, we had quite a lot of weird things. I'll tell you, this Galaxy part, it has a service, let's say a login service. It had one XML file with all the definitions of all versions that have ever been in any message, any request, any response together in a single file. You have 11 versions of the same thing. You try to change the documentation, you change it in the previous version, nobody cares. You change it in the request, no, you had to change it in the response. And it was really massive file of megabytes long. So we managed to fix that part at some point. But during this tenure, 2017 or something, this quick link was a new thing. Galaxy was considered, because of quite a lot of issues, including having XML bindings and whatnot, to be not so stellar, not so good, even though we know it has a nice name. And we invented another better name, quick link. So now quick link was a new thing, and it was JSON or Avro, because it's cool. I mean, everybody likes JSON. Anybody if you likes JSON, smile. There you go, smile. I knew it. Yeah, so, and it's supporting people like it because they understand it. XML has namespaces. We literally have namespaces, like 42 of them. I'm kidding you not. Tid, how many namespaces do you have now? Come on. Just okay, less than 40 namespaces. It's okay. It's okay. So and you had quick link, and the quick link was new, beautiful, and the best part, handwritten. So that's something that it don't do. Now I'll go to the lessons and so on. But one thing is the important part is don't try to do handwritten proxies. They're expensive and they're not scalable, humanly. Even though if they think you can do the better protocol, the more aesthetically pleasing. People like golden ratios, aesthetically pleasing, beautiful images and stuff, beautiful protocols. Don't do it, it's hard, it doesn't work, and it doesn't scale, and you have to maintain it forever. So what we learned from all those kind of fiasco with the protocol, currently we have Galaxy. Galaxy actually has JSON bindings too now, yeah. So, but don't write hand code to provide protocol proxies, to provide protocol bridges or whatever versions of protocol between one thing to another, just to expose it to work better to anyone. Stick to your guns, make versions of your protocols, make your protocols that are versionable, you can roll them back and forth and whatever it's necessary to support them correctly. But don't try too hard at once. You have to maintain it. You make a big change and you find out that it's wrong. What you're gonna do is still have it there, someone is using it. You have at least one customer that likes it for whatever reasons, you know, because they spend money on development efforts, and they did this. So if you want to take something from this one, I'm sure some of you have experienced it, because in our case, we don't have too many web protocols, even though we do have some of them. They're not primarily web, they're custom built, grown for years, decades, more than I have been in the company, obviously. So that's my takeaway from here, and just don't write bindings for protocols.
Now, these were the 8 successful failure stories, and there are some common themes. Obviously, each failure had its own specifics, own lessons, but we noticed that there are at least 2 things that are more or less common to everything. And first is tooling. Tooling shouldn't ever be just an afterthought. It should be integral part of some new development. Otherwise, if tooling isn't right, then the project doesn't just go off. No one likes it. Developers reluctantly maybe deal with this, and maybe they'll find some I don't know, shortcuts to get around of these issues. But what about QA? What about analysts who also want to try out the things? So if you don't have tooling, then no one will like the feature. Another thing is we need to be vocal about all the grievances we see in our everyday life, well, at least at work. When I've been in a situation many times that I see that something's wrong. I don't really like this part. For example, yeah, the tooling, for instance, or anything. For example, a server takes too much time to start up. And I just took it as a fact of life. I didn't do anything. Only years later, I realized that I should have talked about this. We actually did find solutions to most of these issues. But we had to live with these things, these issues for years because no one just talked about them. If we just complain and whine, maybe things get better. Yeah. I hope you learned something.
Thank you, guys. Thank you, guys. That was a very honest look back. So I guess the moral of the story is that you should speak up to bad engineering, right? Perfect. And thank you so much. And this is a small present to you guys from DevClub.
All right.
These are socks. So
Thank you.
The winter is coming, and hopefully they come handy. And
Proper size too.
yeah, exactly. Yeah, it's not that difficult to match the size with male socks, right? And yeah, and
I also want to thank you. So
Right then.
thank you.
All right.
Thank you.
Thank you.
Guys, just if you have anything that you want to ask, even if not now, later, we'll still be around. But if you want to have something to say, we'll be very happy to hear it.
yeah, maybe a few questions. Yeah, we still got time. So yeah, there you go.
So basically, you tried different things. That's why I'm asking what security issues you had experienced and how you managed this.
Security.
Exactly.
Cybersecurity. Most of those things would not be related to security, fortunately for us. At least they're not the protocols. Maybe you mentioned maybe protocols. They would still not be the part that executes the protocol. So, for example, this quick link, it will be a server that transforms the protocols to something else and goes to another server. That part was unchanged and it worked well. Same thing with Galaxy. Galaxy it has its own. Oh, okay, we're out of time. Okay, so the Galaxy part has its own permission set. So that part was we changed it recently, improved it better. When it comes to security, I'd say the thing that I not mentioned here will be login domain for us, which deals with end user directly. Most of the APIs that are mentioned and most of the work that is done is business to business. So in that part it's different and it's not that critical in that way so much. Every entity that connects to us, it's called network, they have SSL client certificates for the most part. So we know who they are and what they do.
No interesting incidents. No interesting incidents.
In this particular, there are just not this one that right here. And there wouldn't. And the point is, they will be relatively easy to teach. Okay.
Repeat the question. Repeat the audience. Repeat the audience.
Yeah, but not kind of incidents that worth mentioning. And most of the things they would have not been this long lifespan. So, anything else, guys?
Over there.
Thank you for the talk. I have a question regarding Hibernate. I feel you. It's first and
I wouldn't say that. Actually, I kind of like it. I like also the giving thing. Nice guy too. I don't think it's terrible. Just our version of the event, I don't agree. But go on.
okay, it's not terrible.
As you mentioned, you moved to some kind of APIs. So my question is, how do you store the data now and how do you access it? From what
Okay.
have you moved on basically?
Okay. So, that was not clear, and maybe we should have mentioned it. And now I know I didn't. The back office is its own model, but it's not primary model. It's just like another service that can access the database. You can think of it. So we stopped doing that, and instead went to the primary service that actually handles the data, this Nova thing that actually exhibit the other problems with other JDR and with Aspect J and all of it. So we forwarded that, and instead of going to database, we ask the primary kind of business logic server to handle the requests for us. This works well. Also, it can take benefit of caching because otherwise, we can't actually use caching in the back office effectively because you violate single writer principle, so you write it in too many places. So we just do the right thing. We don't do the database request from the back office. We go to a service that already has these other things before that you saw them.
regardless, we do still go to database. In that regards, we might not be free from Hibernate, as you asked, but we do it in a more controlled way, in a more isolated manner. For example, let's say we want to return players' name, some credentials, or no, not credentials now. Let's say some personal data. Okay, then we don't have to get some God object, some huge player entity, and then get the stuff out of that. We just get what we need, instead of having huge entities.
Why couldn't you do the same in back office?
Yeah, why couldn't we do the same in back office? That's a good question.
I'll answer this one. I'll answer this one. First, one thing that we do have, and it's really one of the things that for Playtech is going well, and it's one of the best things done, and one of the reasons the entire cloud and everything was attempted and so on, we have ability to execute the request per player, which is end user for us, sequentially interleaving, but not concurrently. So it means that every player has its own queue. This queue is managed in this Nova server with all the problems that it had. So, and doing that in the back office, we introduce just 2 different queues. So all the modifications in a single place, and they're modified and they take a full benefit of caches. Most of the requests, when they come, they don't hit the database. They actually hit local caches in most cases. Some version of cache or some version of data that it is there. Not most of the time we don't hit the database, which allows for relatively nice scalability and that kind of stuff. So we can't do it in the back office because of this part. We have to replicate pretty much everything there. And then you have 2-player queues, which means you can't update them. Because we need to be able to update, let's say, want to change the player name, whatever reason, in the back office. It's not common, but it happens. And we do it by calling a service that actually does it for us. I hope that kind of answers it. Why? Still no?
Why couldn't you use cache in back office?
We have to, okay, I mentioned it again. They're isolated, they work in a single service. Or one of those end users, they always work in a single place. We can migrate them to another one, but they're still in the same place. So if you have more than one server that does it, there won't be. In this case, we need to have replicated caches and so on. So it's really no point to do it. I kind of don't see the benefit of doing it. Currently, at least, because scaling-wise, the system works quite well. We can scale both horizontally, vertically. That is true, and it works well. We eliminate a lot of concurrency issues, or it allows to reason well about what happens at the end, because you can just even look at the logs, so the things executed one by one for specific user. So you don't have them executed in multiple places at the same time. I hope that makes sense, guys.
The last question.
Yeah, the last question.
What do you think? What will be the problem number 9?
Oh no, the problem exists. It's just it just was not in the. I can probably name quite a lot. But
we find it hurts the most.
Hurt? No, just you know, I heard these new guys that they come. They don't know about them. But I have to think the most, because no, if you say one of them just mentioned, and I want me to get just the top of the tops, that's hard.
Something with reporting, I guess.
Yeah, reporting.
But we're getting there.
Yeah,
Slightly.
reporting is okay, fine. But that's not necessarily a bad choice, you know. It's not
Sure.
This let the company, the reporting we mentioned them, and they're really nobody likes them. I mean, at least most of the guys that work don't like them, because they're just SQL. We have reporting that can encompass SQL and JavaScript at the same time. That's kind of reporting we have now. So you can do database queries, and you can process post-process the database results with JavaScript. You have that thing kind of works. But it is hard to do. It's hard to get it right. It's most of the time it has requirements that are given by regulators. They're not internal things. They're not developed. So this is, yeah, I would say probably, but it's not necessarily a bad choice or anything.
That is true, but it does resonate with some of these things. For example, the tooling is not great, and hence people don't really like it.
Well, we get something, this common line thing that works now better, but yeah, tooling is not great. That's true, absolutely true.
You mean JavaScript and SQL together,
Yeah, you can run what you do effectively. You run SQL, you get some results, and you can post-process them, format them, combine them. Yeah.
In the browser, you mean?
No, not really. No, you have that designated server that does that, not a browser.
On
Not
the backend. Okay.
yeah, not in a browser. Not in a browser.
Thanks God.
No, it's just yeah. Depressive.
Can you reveal one good design?
Oh, come on. Something that I mentioned it already. I mean, I'll say this is. I'll take this as top of the tops. I'll say it is the best choice that we have. Ability to run end users in a single, isolated, and consistent way without concurrency for the same request. Actually, this extends even further. We have issues with related players. We have something called related player, which is if you have more than one account or account in the same household, they have to be considered the same person from legal point of view in many cases. So in this case, they share a lot of regulatory framework together. So modifying the regulatory framework or being able to run certain limits and so on, it's very important not to be done in a concurrent manner. So actually, this part, what we have of player queues, they extend to related player queues, which is really hard to manage because they can be related because they have the same phone. Someone changed their phone, they became related, and at that point, they have to run into the same queue as many others. Sometimes we had cases we managed to discover due to bad rules more than thousands or few thousands of them, which is really bad because you have few thousand people that have to run, sequentially in certain ways. So I would say that's probably number one good choice that Playtech has done is the ability to run players in one by one in a certain thing because normally this gives a lot of guarantees to many things, also caching, performance, scalability, all the good stuff. So that would be number one. Okay, good enough.
Perfect. Thank you guys, and let's have a break, 15 minutes, and get back here in 15 minutes for the second talk.
For anybody who's interested in a tour in the office, please gather here behind the big screen. And the rest of you, enjoy the break.
Okay, 20-minute break. Not 15, 20-minute break. Thank you. Ivo, are we ready to start? All right. Ivo says we are ready to start. So, guys, you have a... let's make it 2 minutes. Let's kick off in 2 minutes. Thank you. All right, all right, all right, all right, all right, all right. So, let me please welcome on stage Daniil, who's going to talk about the encryption key management microservice platform at Wrike. Please welcome him with warm greetings.
1, 2, 3. Cool.
And by the way, you're welcome to take your seats. Yeah.
Hi, everybody. My colleagues and I work in one of the most successful project management systems, and we're trying to bring our clients the best product they can have, flexible, tailoring their needs. And today I'm going to tell you about the feature which is specifically tailored for our customers. And let me introduce myself first. Again, I'm Daniil, and I have this thing. And I'm a Wriker, and I'm working in an internal backend unit. And we do things like just monitoring the performance and seeing the bottlenecks, improving around them. We are improving the technology stack. For example, recent Java 17 transition, this was hard. Upcoming Spring MVC integration. And we also take care of user data encryption processes. So what's Wrike? Wrike is a more successful collaborative work management system. And it was founded in 2006. It was steadily grown ever after. And currently it has around more than 1,000 employees around the world and 9 offices worldwide. One of them in Tallinn here. I've been there yesterday. I'm originally from Prague office, which is also quite nice. So yeah, we have a lot of clients. Our clients are small-scaled businesses and huge enterprise organizations with the strict requirements, especially when it comes to security. So what do we need to do? We'll tell about this in this presentation. I'm going to tell you about the feature development story, and I'm going to touch what is Wrike, aka data encryption service we're using internally in Wrike. What is the essence of it? What are the key problems? And whatever came during our development of the feature. And in the second part, I'm going to tell you about the encryption as a service. Why did we need it? How did we come up to it? And some technical details to that project. So Wrike is a software as a service project, meaning that all the data is stored in our data centers, and we're managing all the customer data, which is quite hard. And we work hard to ensure that the data is stored and transmitted securely, but software as a service encryption is vital because you don't want to anyone just hijack your files and be done with your business. So we developed the Wrike lock. The Wrike lock is a feature which helps to manage the secure data storage for our customers by utilizing cryptography and decrypting and encrypting the data on request when reading from the database. Let's dive into the feature. Wrike lock uses cryptography at its core. So for the cryptography, we need the encryption keys. The encryption keys is just a piece of information which you use in the encryption algorithm to encrypt or decrypt the data. Of course, this process is very simplified in this presentation. The encryption requires a separate talk for that. So for this kind of presentation, we just want to see that like data goes out, the encrypted data goes in. Data goes in, encrypted data goes out. That's it, or vice versa for that matter. We have data keys. Data keys encrypt all the data there is to the customer, which can be potentially sensitive, which are mainly strings, because ints cannot be derived. You cannot just derive the sensible information from the integers. There need to be some context to that. So we encrypt the strings. We count every string as a potentially sensitive information for our customers. And when we encrypt the data using the data key, we then store data alongside the encrypted key using this format. We have a device control 1 character in the front, then the data key ID to later retrieve the data key associated with this encrypted string, the encrypted data. So when you take the out data, you can see that this string is in fact encrypted. You see the key ID to retrieve the data key, and you can safely decrypt the data. We have multiple databases in multiple regions and in different platform layers, and we have specifically designed data keys for all of those layers. So this brings us to have a lot of active keys for a lot of platform layers. There goes the management difficulty of this solution. And we don't have only active keys, we also have just deprecated keys because we have a key rotation, which is a commonly used practice in cryptography because we need to rotate the keys. So whenever, every now and then, every company has its own policies on that. But we also have a solution which rotates the key without need to re-encrypt the whole data which was encrypted before. So we just have the active key, which remains to decrypt the data which was encrypted using that active key before. And there is a new data key, which is used to encrypt all the new data. So now we have multiple active keys, multiple current keys, the latest ones, and we all need to we need to manage all of them. What do we have to manage all of them is the account key. The account key is a single key which encrypts all the data keys within the account. Well, Wrike lock is per account feature, meaning that account A cannot encrypt or decrypt data of account B, obviously. So the account key is a single key for the whole account, which encrypts or decrypts the data key. It's stored similarly to how you store the data, how we store data, meaning we have the account key ID and the encrypted data key bytes. We don't need the device control 1 character to see if it's encrypted or not, because we do not store decrypted data key anywhere. That would be out of the policy. So this is a single point towards all the account encryption. Easy to manage, but not so much. Well, here comes the whole differentiator point of the Wrike lock feature. The account key is encrypted and decrypted by request by the client, the owner of the account. And this is done using the Amazon Web Services key management system. So for those who don't know what's that, it's a cloud-based solution which lets you manage your keys. And for this matter, we just call it, like in this presentation, we call it master encryption key because AWS KMS is very complex on its own as well. So client manages each request to encrypt or decrypt the account key, which has the entry point to all the data keys in the account, and as a derivative for that, the data as well. With this approach, client is the sole owner of the whole data, and when he revokes access or something, we cease to decrypt or encrypt any data, which can happen at any time. But with great power comes great responsibility. This is a very powerful tool, and something can go wrong, and possibilities for a perfect disaster are countless. The Amazon server can go down. The client loses access to the AWS KMS, or we lose access to AWS KMS, or anything else. And the businesses, like enterprise-based solutions, they need to recover from it quite quickly and painlessly. So what do? When setting up the account, we have, when setting up the account with the Wrike lock, we have their master encryption key, which is simplified for it's in reality the AWS KMS, ANRs, and etc., etc. So we encrypt the account key using that master key. We have the encrypted account key, we store it, and later on we can decrypt the account key using the master key, using the client's master key. So how do we avoid losing all the data if something goes wrong? Well, during the account creation, we also request client to have a public key, an asymmetric key, which would be used to encrypt the account key. And we'll get a specially encrypted account key using that public key they have. And when something goes wrong, things go south, they should have a recovery private key. We don't know ever about this key, and we just hope that they stored this key somewhere under the mattress, on the post-it note, on the monitor, whatever. We don't care. We need them to recover their data on themselves. That's their responsibility. But we provide that opportunity to them to recover if they lose the access to AWS KMS. So what's the problems? The problem is that every service with the Wrike lock, integrated with the Wrike lock, reads the same databases and sends the request to AWS KMS potentially at the same time, potentially for the same accounts, which is generating a lot of latency. So next, we developers of Wrike went to way of microservices, which is not very easy. And well, the road to microservices is already covered by my colleague, Microservice. And you can check the article on Medium, and there is a Russian version on Hubber as well if you prefer Russian. But in this topic, we will just touch this thing briefly, because actually I wrote the microservices, initiated the project I am about to share with you. So Wrike, in essence, is a distributed monolith. One huge web application where the services are built, deployed side by side. And despite the variety of services, it's still not a microservice platform, because services work with a shared database. And code is just in one huge monorepository. And several modules can contain most of the logic and share it between all the other modules. So what's the solution? Just extract everything into the microservices. That's easy, right? Just take the codes and put it in their separate repositories. Well, yeah, we work hard now to assure that every service can be extracted into their own repository and built and developed on its own. But it's a hard task, and we call, for each of those processes, we call this process a split. And during the split of one service, we discovered a problem. The service is very dependent on the Wrike lock because it's working with the customer data. So it requires the integration with the Wrike lock, the main functionality of which is located in one of those large modules. And we decided not to put all of that functionality, all this module, to the microservice, because most of the logic there is unnecessary for the microservice. And the microservice would be in a different repository, so we need to manage the library for that. And the logic is quite entangled, so it's very hard to just pull out the Wrike lock and then call it a day. And even if we could extract the leap, we don't really want it because we want to decompose this module in the future anyways when we'll take all the parts out of it. So the solution we came up with is encryption as a service. We want to encrypt the data and decrypt the data. There is nothing like difficult to that, but we want to put this in every service which needs the integration with the Wrike lock. And would it be a new service or an older service? There needs to be a very easy integration, just like put the library there or the transition to the new service. So for that, we need a client library, which would do all the work related to the encryption on the client side, which is managing the encryption scopes, which is managing the encryption strategies for different kinds of requests and for different kinds of handles, like system scopes or user scopes, and etc. Then encrypting and decrypting data and communicating with the encryption as a service itself, with the server. So initially we thought that, okay, we have this task, just add the library there and send the data in and out to the encryption as a service. But this is not a very nice approach because the data tends to be quite big in our company, can be potentially hundreds and thousands of kilobytes, which would slow down the communication. And it also doesn't allow us caching for this solution. So in order to address all the points, yeah?
Really? Megabyte size strings to encrypt? Or this is the other type of data that you're talking about?
Wrike can handle attachments also.
So you encrypt.
There is actually one very nice story where the client of ours was using Wrike as a torrent tracker, torrent, but just like putting the videos there and films and stuff. We don't want that, but we need to be prepared for anything. So yeah, no caching, because we just cannot cache the data, which and hope that customer would need this same data in a couple of minutes or so. So in order to address all of the pain points, we decided to work with the data keys. This is simple, much simpler, and the data keys are fixed in size, up to 256 bytes in total, including the metadata. And the client library can cache the keys to avoid the multiple calls for the same keys every time. And so now we have a nice API. We want the current key for the data encryption. When encrypting the data, we want the latest key, which is used for encryption, and the active data key by the ID for decryption. Because as I mentioned before, we have stored the data, encrypted one, and ID next to it. So perfect. We also need to differentiate if the Wrike lock is enabled, because the Wrike lock is a paid feature, and meaning not all accounts have it. And if Wrike lock is disabled, we need to preserve the data which is came to our API, so not to encrypt the plain text data or decrypt the plain text data. But if we want to decrypt the encrypted data, then something went terribly wrong, and we need to notify the authorities. So just to recap, original approach was every service is calling databases and AWS KMS all the time, simultaneously, possibly for the same account. And the new approach is there is a library to the service, it talks to the encryption of the service, and the encryption of the service does its work in calling the databases and AWS KMS. So let's move on to the server part. Wrike lock key management service, which is WLKMS for short and ugly. This didn't work out, so we just call it like this. The benefits of it, of the centralized approach to management of the keys, are fewer points of failure, easier to deploy change in key management, and decreased call in AWS KMS and databases. While calls to database doesn't actually put a lot of load to our system, the AWS KMS calls are the purpose why we have a lot of latency in our system currently for the Wrike block. Because typical amount of time to decrypt the account key is 300 milliseconds. And we got 300,000 requests to decrypt the account key a month for a single server. And this accumulates to around a day of services just waiting to decrypt the account key. And all of this just because we calling KMS for the same account keys from multiple places. And we estimated that implementing the Wrike block key management system would decrease the waiting time by 10 to 20 times. But we still need some caching. And we have two keys, remember? We have account key and a data key. So the data key cache on the server side is not a very nice idea, because we request the data key from the client side to the server, and server needs to just take it from the database and decrypt it using the cached account key. We already have a network I/O latency, so we don't need to. This difference is negligible. But the account key cache on the server side is very vital, because AWS KMS calls are very slow. And also the data key cache on the client library side is vital and very helpful to avoid multiple calls for the same keys on the client side. Now that we have all the caching solution in place, we have two caches, let's move on to limitations, because in Wrike we actually have a limitation of 35 minutes withdrawal deadline. This means if a client withdraws the access to AWS KMS, we cease to encrypt or decrypt any data, and the data is not accessible by us or the client, so nobody. And we went with a straightforward approach of putting the 5 minutes to data cache and 30 minutes to account key cache, which gives us a system where the maximum withdrawal time is 35 minutes, which might be hard to grasp at first, but let's review the example. So suppose the client sends the request for a data key to the encryption as a service. Encryption as a service requests the decryption of the account key from AWS. It receives the account key and sets a timer for 30 minutes in the future to remove this key from the cache. And it gives back the key, the data key, to client library, and everyone is happy. The client library has the key for 5 minutes, which in this example doesn't matter because we're looking for a maximum withdrawal time. So suppose in future, somewhere in future, just before account key cache is expired, any service would ask for a same data key or the data key which associated with the account. The data key can be provided immediately because the account key cache is not yet expired. So it gives it back, and then the timer goes off. Now we have a 5 minute, for the 5 minutes we have data key cache, and the account key cache is already expired. So it was expired. The data key was taken at nearly the end of the life of the cache on the client, on the server side. So the next, any next request for the data key would initiate the AWS access. And if we have withdrawn, if the client withdraws the AWS KMS access, then we will not have the key. So we had received the key for 5 minutes after 30 minutes from last call to AWS. And therefore, we have maximum possible time of less or equal to 35 minutes. Well, this approach already satisfies our needs, but we decided to go a little bit further to satisfy the most used accounts. And we came up with the idea for asynchronous cache wrapper, which would wrap the caches we have and present their sole functionality of providing the requested key at any time. But if the request came after the half-time of the key, it would request a renewal of the key at the same time. Let's take a look at an example, because it's kind of hard to grasp as well. So suppose any client or the service, it doesn't matter, it's a cache wrapper, it's agnostic. So it requested a resource the cache requests the resource from the provider. Provider gives the key. We are having here the example on 5 minutes for the data key, for example. And the cache gives back the callee its key. Then 2 minutes passed. We still have 3 minutes. We request the resource. Cache gives it. It has it. Now 3 minutes passed, which is more than the half time of the cache. And we request the resource. So the cache has the key. It immediately returns the key to the callee, but it also at the same time requests the resource from the provider. Now the callee has its key happily, and we receive the key from the provider, resetting the cache time to 5 minutes. And this solution, downsides are that we have double the calls to AWS KMS, and we have double the calls to encryption as a service. But the upsides are that there would be infrequent worst case only for the first time when a user goes into account. So in the morning, maybe the worker goes to his PC and opens the website. There's a first request. We request all the keys, and now we already have all the keys in cache. And if the user or users, any user of the account uses it for more frequently than once in 5 minutes, then we always have the key. And second worst case is kind of eliminated as well, but still present in some cases. And the second worst case is when only the account key cache is present and initialized. And when this second worst case happens, only when the service connects to the encryption as a service. And when it happens, well, in Wrike, software as a service, we are providing our services at all time, and we cannot allow any downtime. So when we deploy the applications, we have our services running. Then we deploy the new versions of the services to another server, or like site server. We redirect all the traffic there. We update the first one, and when we redirect the traffic back. At that time, all the services which were initialized, the first call would be in the second worst case. But the last case is the best case, and it's very frequent for mostly used accounts. So if the client uses the account, as I said, more than, or at least once in 5 minutes, then all the services would have the key immediately. So what's the conclusion of this story? Well, encryption key management in software as a service is very challenging, and it should be robust and responsive. We need the keys at all times. We don't want to wait for the account keys or any keys to be deciphered or taken from the AWS KMS, which proves that AWS KMS is a very powerful tool when used correctly. And, well, transition to the microservices can reveal the pitfalls you couldn't imagine, because we couldn't thought that while reworking on a small project, we'll hit the milestone of the need to rewrite the whole encryption process of the Wrike lock. And that's basically it. Thank you very much. It was nice. Read about our company. We have Wrike Engineering and a tech club as well. So, and if you have any questions now, don't hesitate to ask.
All right, let's go with the questions. Stanimir, yeah, you go.
About the duplicate calls to AWS KMS. Why don't you send the calls only if you close to expiration or half the time of the cache? So let's say in 5 minutes, you only make calls to AWS after only 2 minutes are left. You don't need to refresh the keys all the time. You don't need to double them.
It's free. You can do whatever. We just because, and also this is a good point actually, because if you'll make a call, because the account key cache is 30 minutes. So for example, you're asking why not like 2 minutes before the end but 15 minutes before the end, right?
No, why you said you double them as a downside? You said you double the codes.
Yeah. So double is 15. So we're calling the AWS KMS 15 minutes before the account key cache expiration, not 2 minutes, because if we will call it and we'll see that something went wrong and we don't have any contact to AWS or the access is withdrawn, we have 15 minutes against 2 minutes of time to prepare for our inability to decode or decrypt or encrypt anything. So we can contact client, for example, and ask like, hey, did you withdraw the access? No? Well, then we will resolve our issue on our own.
I have a question. How would you explain to a 12-year-old why do you need all this logic on top of KMS? Why can't you just proxy everything to KMS or any other
Yeah, like HashiCorp or something.
Yeah, like Vault or something like this.
Basically,
12-year-old.
12-year-old, yes.
What is the encryption?
Imagine a 12-year-old who knows about KMS and what encryption is.
So our clients, they want the control, but often they don't have the resources to build the control over it, the responsive control. So providing just a single point where you click yes, no on AWS, and the whole data is encrypted or decrypted, can be encrypted or decrypted, is a very nice win for our clients. They don't need to think about much. We are doing it ourselves.
Yes, but imagine that under the hood, so basically, there's a kind of, a toggle that, encrypt all my data, right? And you download the key as a customer, right? And only you have this key. But then it basically passes through this key to KMS, and that's it. That's all it does. And would it or would it not that work? Or like, why do you need everything else?
If they will be encrypting all their data themselves and decrypting them on themselves, so they will need to come up with a key management solution for their system and their employees who are using Wrike.
So basically, it's like to manage keys, right? So
yes.
Okay. Gotcha. Thank you. Any other questions?
Sure.
You said that some client stored videos from torrents, but if you encrypt all the data, how do you know it?
Because we contacted that client. Well, No. Actually, this client did not have the encrypted torrents. It was just torrents. I mean, like movies and stuff.
Right. I think we have a capacity for one last question. All right. Yeah, you go.
Do you also index your data for searching and things to encrypt the search index?
No, we don't index the encrypted data.
How do you work with the search? Right? You want to search, navigate the project really quickly. You say, "Oh, you encrypted the data. This is it, right?"
You cannot search based on the user data.
You can search based on data, right?
Yes.
How do you do it? If everything is encrypted?
They have the decrypted data on their end, and they can search, like, for example, we have the window where you have the tasks, right? So you search on those tasks, not like on the back end, but just on the front end, because we cannot have control. Like, we cannot just decrypt the data on request and like search among it.
So it's basically, if it's decrypted, they can only search through what's been loaded in the browser.
Yes.
Okay.
How what? Concatenation or sorry? I would be able to answer your question if I would be working in another department, but I don't take care of this particular case, so it works. Magic.
Perfect, perfect. Thank you so much, Daniil. This is to you.
Thank you.
From DevClub, a small present, and then.
Thank you.
Thank you. So, Kat, what is the plan? Do we wrap it up, or do we still have people hang around, or? So yeah. From the DevClub side, this is it. Like there gonna be no more talks tonight. Well, thank you so much for joining us. Thank you so much, Playtech, for being such an awesome host. Hopefully we also managed to make a good impression, and this is not the last time we're around. And the next one, stay tuned. It's gonna happen in December at Eesti Energia preliminarily, and see you in a month. Thank you. Bye bye.